On space as critical infrastructure. One of our panelists, Sam Visner, he wrote recently in Politico that it's time to declare space systems as critical infrastructure to prevent cyber attacks that cause them to malfunction or collide or worse. And right now there are 4,000 active satellites, and by 2030 the estimate is that there will be 50,000 or more in orbit. So we have a great panel today that's going to tell us what exactly is happening up there in space. We have John Galler with us. John is the Assistant Vice President for National Security and Space at the Aerospace Industries Association. We have Sam MITRE, who's a technical fellow, Sam Visner, who's a technical fellow at MITRE, and our very able moderator today is Jo Marks from the Washington Post. Unfortunately, Erin Miller, she was supposed to join us from Colorado. She was unable to join us as of yesterday, so thanks for your patience. Please welcome to the stage our fine panel and moderator. Thanks.
Hello. Thank you so much for joining us today. So as Niam just said, this is titled Space and Critical Infrastructure. Space is probably pretty self-explanatory to most people, but the rest of that might be opaque. So I thought to just lay the groundwork a little bit, we'd start by asking, John, can you tell us what exactly is critical infrastructure? And then Sam, why should space be treated as critical infrastructure? And what would that mean?
Yeah, no, great lead off. And I think I like to look at this as there's two CI, critical infrastructure. You get the lowercase and the capital. The capital are those actual 16 sectors that DHS CISA has declared as so vital to our nation's function. We need to make sure and protect them. And then there is this lowercase that, hey, is space really critical to everything we do? I think space provides an avenue to apply all instruments of national power. My background is national security side, but really space can provide all of that. And so I don't think there's any debate about whether the lowercase CI matters for space. I think it is certainly critical. Though certainly recently, as Sam has written, there has been debate cropping up about whether it should be one of those actual formal sectors, make it the 17th one. And I'll hand it over to Sam for his thoughts on that and why.
Sure. Thank you, Joe, and thanks, John. It's a good question. I guess my own view on it is that to some extent we have to ask the bigger and more sort of all-encompassing question, and that is, what is our national interest in space? To what extent do we depend on space systems for our national security, our economic security, our economic competitiveness, our technological prowess, or even dominance, our critical infrastructure, and our global commitments? Once we have an answer to that question, and I think we can sort of infer what that answer might be, we can then ask ourselves, all right, what do we do about it? The answer to that is clearly it's critical. Space systems are critical to all of those things. And whether we call it a sector of critical infrastructure or not, what we think we need to do, Joe and John, is to choose an appropriate set of tools that allow us to protect, that allow us to ensure the security and resilience of those systems. A declaration of space as a critical infrastructure sector would be, I think, a useful thing to do, but it's not the only thing we might do. And it's but one of a set of tools, which includes the right kind of collaboration between government and industry, the right kind of information sharing, the right standards, the right processes to be able to push good security and resilience into it. We've asked ourselves how critical this really is. We're coming up on what, over now 4,000 satellites in orbit. Companies like SpaceX and Blue Origin and others are becoming the new hyperscalers. Think about 40,000 satellites in one constellation, in a global 5G constellation, hooked to a global cloud infrastructure, hooked to billions of IoT devices, serving government agencies and enterprises around the world. Space systems are going to be critical to that, and that kind of hyperscaler infrastructure is something that I think is about to emerge. We should also not forget that there are a number of missions unique to space. Yes, space is part of our communications infrastructure, but it's also part of our remote sensing infrastructure. It's also key to our weather forecasting infrastructure, to our global position, navigation, and timing infrastructure. And many aspects of the industry are unique. launch services, the fabrication of rockets and satellites, the entire supply chain, some of that is absolutely unique. So protecting the security and resilience of all aspects of all those missions and all those infrastructures, and that new hyperscaler infrastructure emerging around the world, that's critical, certainly.
And as John mentioned, this critical infrastructure designation, capital C, capital I, is largely a post 9/11 concept, and it's about threats from terrorism, threats from hacking. What are the threats we're facing from cyber attacks in space? John, can you start with that?
Yeah, I mean, really, there's a lot. Imagine anything that you've seen cyber attack on terrestrial assets, and apply that to space. And so, you have data monitoring intercept. So you can go ahead and intercept transmissions, be that remote sensing data, be that sensitive communications, things like that. You can corrupt that data, right? So you may be relying on that as critical infrastructure, certainly relying on some of these satellite data capabilities. You can potentially even take over a satellite, and that has some real implications. There's a whole continuum of counter space capabilities, from non-reversible to reversible, from non-kinetic to kinetic, and cyberspace can really represent all of that. And I think it's it is really a growing threat. It's also asymmetric. It's a lot cheaper to develop a capability cyber-wise to offset a space capability that may have cost you quite a lot of money and that the nation really relies on for something. So it's something really to get our hands around, and it's something that is not as easily visible as when we see direct descent anti-satellite missile launches, as we see United States Space Comm come out and say that other nations are actually performing on-orbit weapons testing. It's not like that, and it's not as easy to see, and we haven't seen it so much on the space scale, but it's there, and it's certainly a vulnerability we have and have to be careful about.
And Sam, can you run through a hypothetical or two for us? Because I think we've already seen to some extent the way a cyber attack against critical infrastructure can affect the nation with Colonial Pipeline attack. That was criminal ransomware against a pipeline. We can sort of imagine what it looks like, having looked at Ukraine, when a chunk of the energy grid goes out. What would a cyber attack against a space system look like hypothetically? What could happen?
Sure, and that's a really timely question for several reasons. First, cyber adversaries operate for they have a couple of motivations. Sometimes they're seeking out a specific target because they want to steal money or steal intellectual property or cause damage. In some cases, they're opportunistic, and they will take a look at an industry and choose a vulnerable player. They'll go after the weak one in the herd. And with space systems becoming far more complex, with thousands of satellites and a huge global supply chain, we need to look at those vulnerabilities. The other reason, of course, right now is that the Space ISAC, on the Space Information Sharing and Analysis Center, on which board I serve, is conducting a series of tabletop exercises. And things at which we're looking would be going into the command and control and navigation of one satellite and maybe causing it to collide with other satellites. That's a possibility, by taking control of it, or jamming the command and control and the navigation systems of satellites such that their orbits are no longer necessarily predictable, which has two knock-on effects. The first is they don't do the job they're supposed to do, and the second is they may hit other satellites and cause a great deal of damage. There are other things about which we would worry, Joe, and that is an attack against a ground station, and not just a cyber attack, but conceivably a physical attack. And one thing that worries me as we move forward into this more complex hyperscaled infrastructure around the world and this more complex and varied supply chain would be opportunistic ransomware attacks against specific operators, against specific systems. And as we've learned, we rely more on them than we ever have. An example that is obvious when one thinks about it, but actually isn't obvious until you do, is the nation's food supply. We use precision navigation and timing to navigate the trucks that bring food from farms to supermarkets. But even on large farms now today, farmers are using escape. So an attack against any of these systems could harm infrastructures that wouldn't have been obvious, including, for example, the nation's food supply.
John, how has this threat changed and mutated in recent years as more and more of space has become commercialized with SpaceX, Blue Origin, and things like that?
Yeah, absolutely. I mean, the commercial use cases 20 years ago versus today are incredibly different. It's really even hard to predict where we'll be 10 years from now, but there is a reliance on that, and there's certainly government reliance on that. So we have dual use capable satellites that you know, we actually sell to both the government and the commercial markets. You know, it's really interesting to look at where we've traveled with this, and I think if you look back to last summer, we had the previous National Space Council and the administration release a Space Policy Directive 5, SPD 5, that actually focuses on cybersecurity. So we've really seen in a very short period of time us start to coalesce upon this issue. The National Space Council was terminated in the 90s, was brought back in the previous administration, and now has been retained in the current one. So I think we see some continuity there that not only acknowledges cyber, you know, and the threat that we're facing there, but space is being critical to our national security, to our everyday American way of life, to our global economy. And so we're starting to see that. You're also starting to see some things crop up. So while it is not a critical infrastructure sector, DHS CISA has actually looked at what can space bring into the fold without that critical designation. And so there is a cross-sector working group. Sam and I are both members of that. And so it's starting to at least look across all those sectors. There are 55 national critical functions that we perform, and space it either has dependencies or uses in all of those. And so it's reaching out. How is space working with agriculture? How is space working with energy? How is space working with healthcare? And it really does have ties into all of those. So can we find some of those gaps and seams absent the critical infrastructure designation? Because whether that happens or not, we've got a challenge here and have to get after. And that, you know, I think the working group is a public-private partnership that we've got. You know, I'm the industry lead there. We're working with the government to try and really enable that cross-sharing of information, because it's a challenge we have to get after regardless of whether it becomes the 17th one or not.
Yeah, and you bring up an interesting question, because there was a good article in the publication README that came out just today on this topic that makes two related points. One is that most space assets are part of a critical infrastructure sector right now. They're just not their own sector, because there's a defense and industrial based sector, there's an IT sector. As you mentioned, all of these implementations have their own sectors like agriculture and healthcare. The other one is that DHS now is beginning to find the critical infrastructure sectors somewhat unwieldy, and is trying to narrow down into, one of the names for it is strategically important critical infrastructure, where you try to narrow down, here are the things that really matter rather than this broad sector concept. How do you think about that, Sam? And is the broad sector concept for space still important?
Well, certainly I think it's important. You know, if one goes back in history, one could have argued, although I'm not sure I would have made this argument myself, that space systems essentially are, if not derivative, are embedded in other missions, communications, for example. But I think even going back 10 or 20 years, a lot of that infrastructure is absolutely unique. And it has its own supply chain, and that supply chain requires its own very specialized security. Look, even the tolerances associated with space systems and the risk management approach for space systems is probably more stringent than it would be for any other infrastructure. Because a failure in a space system can be catastrophic. It can destroy the system in question, and in some cases it can even be deadly, as we've learned, sadly, to human beings. But you know, this reminds me of the conversation about cyberspace, and I was interested to hear General Milley's comments as well as General Nakasoni's comments. We argued for a long time, is cyberspace really its own domain, or is it just an electromagnetic domain in which we move information back and forth about the real world? We have, what, 7.6 billion people on this planet, 4.3 billion people are connected. Cyberspace now is a realm of state power. It is a realm of global influence. And therefore, it can't simply be treated as derivative of something else or a subset of something else. Space systems, I think, also enjoy this same quality. And one, I think, whether or not one uses the traditional critical infrastructure sector designation under Presidential Policy Directive 21, or moves to this new sort of more compact and all-encompassing definition of critical infrastructure sectors, I think we have to recognize several things. First, space can be an advantage for this country. Second, almost every critical function on that list that John mentioned is dependent on space. Third, other countries see this as an advantage for themselves. And fourth, they see our vulnerabilities in space and space systems as a way of gaining an advantage over us in great power competition. So for those reasons alone, I think one has to regard space as a specifically important critical infrastructure sector.
John, did you want to weigh in on that?
I mean, I'll just pile on. I think looking at this from a national security perspective, we had a combatant commander and the chairman in this morning, right, and talking about from the military perspective. I'm really glad that General Milley brought up space and the importance. It's getting talked about at the most senior levels of that. But there are larger ramifications than that too. Space, as we're sitting around with COP26 going on, space provides so much down to examine climate, to take a look at Earth sciences, right? I mean, it provides us more than just weather forecasts. We can see sea levels, we can see methanes, we can track wildfires. We talk about agriculture, overspraying of chemicals, things like that, right? That it really is interwoven into our complete fabric that is going to have ramifications on the national security stage beyond just those military and intelligence community capabilities that we traditionally associate with national security space.
Absolutely.
So we are, well over half a century into the space program at this point. Space has been recognized as a domain of conflict for decades, and certainly we've been working on space much longer than we have on cybersecurity, at least as it's currently understood. Why do we find ourselves in this position? Why are we so far behind in working on this?
I don't know that I would say we're so far behind. I would say that the situation has changed. We had, in the recent past, relatively few number of space systems. These were bespoke systems. They were built with their own resilience and security in mind. They were tightly controlled. We began to see over the last couple of decades an expansion into commercial space, but still a relatively small number of these platforms were available. What's happened recently is essentially a state change, an order of magnitude, perhaps coming up on 2 orders of magnitude in the size and complexity of these infrastructures. Let's talk for a moment about SpaceX. They've got close to 2,000 satellites up there. That's amazing, 2,000 satellites. 60 satellites are launched at a time, sometimes 2 launches a month. Their initial goal architecture is 12,000 satellites. Their eventual goal architecture is 40,000. Blue Origin, 3,200 satellites, I think, is their goal architecture. And if there's anyone here from Blue Origin, they can bring me up to date on that number. Planet Labs has built an extraordinary ability to do imaging from orbit. One has seen perhaps the resolution of the photographs they've taken of suspected new Chinese ICBM fields. So what I think we're seeing, Joe, is not necessarily that we're behind, but that all of a sudden there's been an explosive expansion in the size and complexity of these systems. And that has been accompanied, I think, by some interesting statements. You may know that the Intelligence and National Security Alliance released a paper, I think, yesterday on this topic. Aspen itself has spoken on this expansion of space systems and the need to protect it is critical for the nation. So I would say that what we're doing is yes, we're playing catch up, but we're playing catch up to a situation that has changed significantly recently. Look, 2-3 years ago, we were not using the private sector to put human beings in space. Now in this country, it's pretty much exclusively that's what we're doing. So that also is essentially a fundamental state change in the situation that requires our attention.
John, you're nodding.
Yeah, no, absolutely. And I think we have to think about space as inherently global too, right? It may be that we want to protect the U.S.'s interests in our space capabilities, be those commercial, be them civil, but think about it, right? So we have the satellites. So that's the first thing we visualize, though we can't physically see them, but that we think about that being threatened, right? And what can we do to threaten that? There's also the links. So the links going up and down to the satellite to communicate with it. Sam talked a bit about that. How can you corrupt? How can you block? How can you change that data? Then there's also the user segments, right? All of your phones get space signals to them, right? And so whether you're using GPS or communications. There are millions of user segments, probably billions, that you have to be concerned about. And then there's the ground stations themselves. And I think that's really interesting. So I grew up as a national security space operator, and no kidding, I was operating with a trackball and a push button mouse, and this was 10 years ago? I mean, not that long ago. But the growth has been so fast. Now, I mean, we're at the point where you can control a satellite from your cell phone. And it is not somebody having to be present 24/7, typing codes on a keyboard. With these larger constellations, so much more of it's automated. And then additionally, we bring in the cloud network, right? And so that manages some of our connections to these satellites, the data that they go through. So I just feel like there's so many touch points that have come as we have developed new technologies and found new uses for space, that you're naturally going to have more points that you could find exploitations.
So let's say theoretically the Biden administration just makes space critical infrastructure. What happens next? What do you want to happen both inside government and in industry?
There are several things that could happen next, Joe. First, I think a stronger interagency mechanism could be built to work both within the government and with the private sector. There are several places where this might occur. I'm curious to see and would be thankful for some recommendations on this from the Solarium Commission, which Congress stood up a couple of years ago, and it continues to make very useful recommendations, some of which are being implemented in law. There is a Presidential National Security Telecommunications Advisory Committee, the NSTAC. They've worked on a cybersecurity moonshot. I would think that one of the things that they would do in advising the Oval Office might be to extend their recommendations to the security and resilience of space systems. We could also strengthen the information sharing that is provided by the government to the private sector, and we also ought to remember that as the private sector, as the commercial space environment expands, so does its attack surface. And that means that its attack surface can be a valuable source of cybersecurity information for the federal government, something that I think is people are aware of. The Space ISAC has achieved its initial operating capability for its information sharing portal, and what I'd like to see would for this to become bilateral. At some point, and I think you may be aware that there's bipartisan legislation on the Hill that's been proposed by Congressman Liu and Congressman Calvert that would cause the designation of space systems as critical infrastructure. If that bill is passed, or something like it is passed, the next step would have to be the designation of a sector-specific agency with lead responsibilities for pulling this together. And at some point, these responsibilities probably have to result in resources and programs and the assignment of responsibility for executing these programs to gain additional national capabilities. So I think that kind of designation would give us these benefits.
Do we need more regulations on space systems?
Right now, so when SPD 5 came out, the National Space Council was actually very open to industry input. And our initial take to them was, let's not make this so prescriptive. Let's take a risk management approach. The threat is changing so fast and so quick that sometimes some of those regulations may not actually get after the issue. So how do we bake this in from the beginning? That's something that industry is obviously looking at very closely. Space is capital intensive. It is very expensive to develop systems. It's very expensive to launch them. And while that's still coming down, when you're looking for that kind of cash flow up front to go after a business operation in a case, you have to certainly make some strategic choices. And I think the interesting thing to do is to go out and make those cybersecurity choices up front, understanding what that benefit's going to provide on the backside.
I want to dig in a little bit to what the cyber threat is here. In a lot of these critical infrastructure sectors, you have a division between the front-end computers, which are run in Microsoft Word and all of these things that hackers know a lot about, and then you have back-end systems that are much more bespoke and tougher to get into, although certainly not impossible. And one of the real problems is when those two are connected. Is that what's going on in space systems also?
To some extent, Joe, yes, and yes, that's a good question, and to some extent, yes, that is what's happening. If one takes a look at space systems, the information technology component is very complex. There are the command and control systems that are used to manage these constellations and to ensure that satellites are flying in the right orbit. There are onboard systems which take care of the health and overall functioning of those satellites. And there is the workload that those satellites support, whether or not it's for space imaging or for precision navigation and timing or for communications or for weather or new missions like manufacturing, which I think will start to take place in space, and of course travel. Mining may take place in space. We're talking about that and more exploration. These are onboard systems. And last but not least are the more common information technology back-end to which they link. And I would say that one thing about which we should be concerned is the fact that these systems probably are more closely linked than they used to be as we start to connect these onboard infrastructures to terrestrial cloud infrastructures. And Joe, there's one last piece I want to mention, and that is the information technology used to manage the supply chain. Thousands of manufacturers, millions of parts. How do we know where the parts came from? How do we know they've been tested to the right standard? How do we ensure their provenance, and how do we ensure their authenticity and their integrity? This is a problem that isn't unique to space, but probably with space systems, given their criticality and their complexity, is more significant to the space sector perhaps than to any other.
Do you have some short and terse audience questions? One right here.
Gentlemen, thank you for joining us today. My name is Patrice Smith. I'm one of Aspen's rising leaders. With the creation of the Space Force, is the U.S. military structure optimized to advance U.S. interests and protect critical infrastructure now, in your opinion? Or what other structural changes would you suggest?
Yeah, so Space Force, it was a bipartisan stand-up of a service. General Milley recognizes it. Now General Raymond has a seat within the Joint Chiefs. We have it. We brought it out of U.S. Stratcom into U.S. Space Command to really symbolize what space is as a warfighting domain and the capabilities it brings to the fight. I think it is positioned to certainly protect those national security space capabilities. The debate is out there still, though, of there is a commercial sector. There are other civil capabilities that NASA or NOAA use, right? And so that is something that we have to consider with taking care of. Space Force's charge will not be solely to go take care of every commercial space capability out there, though through its stand-up and through very significant funding that has increased year after year on a bipartisan basis, it is standing up to really get after a lot of those threats and challenges.
Time for one or two more. Here's one up front.
Thank you. George Nicholson with the Global Special Operations Forces Foundation. About 2 years ago, we had a conference over at the Atlantic Council with the Commandant of the Marine Corps, General Neller, and he stood up and said, what's the biggest threat the Marine Corps faces in the future? And his answer to it was our dependence upon GPS and SATCOM. He talked about the previous month being in Afghanistan and asking some of his Marines to show him on a map where something was. And they said, sir, we don't use maps anymore. I got my cell phone and I've got my tablet. 2 weeks later, I was on a meeting with the Chief of Naval Operations, and he laughed and said, you've been reading my emails. We've got the same problem. What are we doing right now to ensure that we've got the capability, particularly with what our adversaries are putting into space, to have a backup system?
Well, actually, that's a great question. I can't comment, actually, on what we might be doing, largely because I'm not involved in that. What I would say, though, is that our concern about the potential vulnerability of these systems and our dependence on them is something that's widely understood. And I do think work is probably underway to improve the integrity of them. But what I would also say is that our dependence on them is growing. If one takes a look at the battlefield of the near future, it's going to be a 5G-enabled battlefield with information flowing at perhaps terahertz speeds at some point as we move beyond even 5G to whatever people call next G. And much of that is likely to be space-based. So whatever we do, we're likely to see more dependence on space systems for logistics, for expeditionary forces, for on-scene battle management, for reconnaissance, and for command and control. So I think you're asking absolutely the right question. I wish I could give you a better answer as to what we're doing to improve the security and resilience of those systems, because it's absolutely vital that we do.
Thanks, Sam. Thanks, John. Thank you, everyone. And sorry for those we didn't get to.
All right, thanks everybody. Thanks to our wonderful panel. Thanks. We now have a brief break. We have 15 minutes to collect lunches before we have Secretary Condoleezza Rice in conversation with Margaret Brennan. So bon appetit, and we'll see you back with your masks on at 12. Thanks.